Hey guys, these are your notes for 11-3 day 1. So just a brief overview. Really, it's just a refresher from pre-cal. These are pretty much the notes that you copied in pre-cal a couple years ago. So refresher on polar functions, how to write polar coordinates, how to toggle between polar form and rectangular Cartesian form. So just a reminder that an ordered pair, a normal ordered pair in rectangular form can be converted to polar form. And what we need to do is we need to figure out what the radius would be. So that's our hypotenuse. So from the origin, how far out are we going to go, farther than my x? How far out are we going to go before we rotate through an angle of theta? So what's the length of the hypotenuse that we're going to rotate around our axis? Usually, polar coordinates are written with brackets. I mean, sometimes you see them with parentheses, but oftentimes they're written with brackets. And then, let's see. Yeah. Polar coordinates can be written with a positive radius, meaning let's start at the origin. Let's move out on my x-axis toward a positive direction before rotating through our angle. Our angle could be negative, and our radius could be positive, which means let's move outward a length, a positive this, and then let's move in the negative direction to get to our point, right? So both examples use a positive r, so we're going positive on our x-axis, positive angle, positive r, negative angle. Sometimes r is negative. And I'm going to show you two ways to come up with the point and or the angle if r is negative. So let's look at this over here. This point right here has a negative r value. How do you obtain this? Well, one way is to look at the positive direction, go out positive 2, go up an angle of pi over 6, and then just with a line, follow it back into its opposite quadrant. So this point right here has the polar coordinates, -2, positive pi over 6. How would you graph it? Again, you would go out a positive 2, up a positive pi over 6, and then follow it back with a line. The other way, and I kind of like this way better. I don't know how pre-cal students would handle it, but you all can handle this. Start here. Go the negative direction on your x-axis. So come out here a distance of -2. Now, ready? Remember how positive angles go in this direction? So come out here a distance of 2 in the negative direction. Now, travel an angle of positive pi over 6. That would put you right there. And then there's no line and trying to follow it back. So you can either do positive, and make a line to follow it back, or just go the negative direction and then rotate through an angle of pi over 6. Some people have trouble with this method because once this angle gets bigger and bigger and bigger, sometimes people have a hard time calculating, oh gosh, where am I going to end up if I started here? I can start here, and I'm okay with ending, but some people have a hard time starting here and doing this much rotation. All right, so the relationship up here between theta, x, and y, and r, and we did this in vectors the other day. We know that sine of theta is opposite over hypotenuse. Therefore, y is equal to r sine theta. Similarly, cosine of theta is equal to adjacent over hypotenuse. So I can say that x is equal to r cosine theta. These two right here are my formulas to convert from polar coordinates to rectangular coordinates. If you want to think of them as in ordered pair form, you can say as an ordered pair, it's r cosine theta, because that's your x value, r sine theta. That's your y value. So if ever you're in polar form, you've got the radius, you've got the angle of rotation, and you want to convert it to rectangular form, you're going to do this math to get you your x coordinate, and you're going to do this math to get you your y coordinate. Polar to rectangular, so that's r comma theta, holy moly, I'm struggling, r comma theta to x comma y. And over here, what if we start in rectangular? So what if we start with an ordered pair? How do we convert it to polar? So the first thing you're going to need is you're going to need to figure r. Well, that's just your hypotenuse. R is equal to, do your Pythagorean theorem. Super easy. And then how do you get the theta when you've got the x and the y? Come back up here to the picture. How do you get your theta when you've got your x and your y? You're going to do tangent. Tangent of theta is going to be opposite over adjacent. Usually I don't start with, usually I just use a reference angle. That way I don't have to deal with positives and negatives here, but we'll do that in a minute. All right, a little bit of practice just naming polar coordinates. So let's graph the polar coordinate 3 comma pi over 4. I'm going to come out 3. I'm going to go to pi over 4. Right there. Radius is 3. Angle of positive pi over 4. Now, I want us, to name this point 3 other ways. We've got one way right here. Positive r, positive theta. Let's name it 3 other ways. Don't get super crazy and say, hey, let's swing around and do like 8 rotations and see what our angle is. Let's just do within 1 positive rotation and within 1 negative rotation, okay? So let's look at what if we keep r positive. Let's make our angle negative. So keep r positive. How are we going to get from here to here using a negative angle of rotation? Well, you know that 1 complete revolution is 2 pi, and this reference angle right here is pi over 4. So that would be a negative angle of 7 pi over 4. Okay? Positive r, negative angle of rotation. Now, let's do a couple of negative r's. I don't know which way you prefer, but I'm going to like look out here in the negative direction, and I'm going to see what this, remember angles this way are positive. I'm going to see what would this positive angle be to get all the way to here. So 1, 2, 3, I'm going to go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, positive 5 pi over 4. Now I'm going to go the other way. Start here. Go in the negative angle direction. 1, 2, 3. That's a negative angle, 3 pi over 4. There you go. Named it 4 ways. Moving on. Convert into polar coordinates. We need r. We need theta. That worked out nicely. We need theta. First thing I'm going to do, instead of actually looking at theta, I'm going to look at the reference angle. We need theta, but first, I'm not going to deal with positives and negatives. I'm just going to find the reference angle. So I'm going to go tangent for my reference angle. Remember, that's going to be acute. That is just, forget the negatives. Opposite, adjacent. So my tangent fraction is 1 over radical 3. Tangent fraction is 1 over radical 3. That would be a reference angle of pi over 6. Reference angle is pi over 6. Now, to get theta, the real angle, I'm going to place this on a graph. So this point actually is in quadrant, let's see, positive. This point is in quadrant 4. What is theta? If this is my reference angle, what is theta in quadrant 4? It's 11 pi over 6. Theta is 11 pi over 6. So my polar coordinates, 4, comma, 11 pi over 6. All right, let's do it again. We need r. Okay. We need theta, but first, I'm just going to find my reference. Tangent for my reference is 1/3. Okay, that's not a nice one. That's not on my table. That's not on my fingers. I'm going to have to use my calculator. Well, I've got it written down. I found my calculator. My reference angle is about 18.4 degrees. I'm not really sure why I'm in degrees, but I am, so okay. And then from there, let's figure out theta. So I'm going to place 3 comma negative 1, 3, oh, I'm in quadrant 4 again. Quadrant 4 again. And my reference is 18.4. So theta is going to be 360 minus 18.4. There you go. There are my polar coordinates. All right, let's convert the other way. Let's go from polar to rectangular. Polar, rectangular. I need x and I need y. And these are pretty easy. X is r cosine theta, r cosine theta, y is r sine theta. Alrighty. Cosine, 11 pi over 6. Ooh, this takes me back a ways. 11 pi over 6 cosine. That's radical 3 over 2. Radical 3 over 2. But quadrant 4, ASTC, positive. Sine 11 pi over 6, 1/2. Quadrant 4, ASTC, negative. All right, so to rectangular. My rectangular coordinates are negative, positive. And a real quick check on that is, at least from a positive negative standpoint, look and see where this would be if you graphed it. So -3, almost 1 complete rotation, is going to put you in quadrant 2. And a negative x and a positive y also puts you in quadrant 2. That kind of eases my mind a little bit and kind of makes me think, I think I did that right. All right, let's convert equations. So right now I have an equation in polar form and I need to change it to rectangular form. So here's where you're going to, it currently has an r. How is r related to x and y? If I'm going to get it to a rectangular equation, I want it in terms of x and or y, usually both, but maybe not. Does R have a direct relationship to x and y? Well, heck yeah, it does. It's right there. R has a direct relationship to x and y. So I'm going to, in my polar equation, I'm going to take this out and sub in what it's equal to in its place. Whoa. So I'm going to sub in radical x squared plus y squared. I'm subbing that in for r. X squared plus y squared is equal to 9. Whoa! That's an equation of a circle. That's an equation of a circle, centered at the origin, radius of 3. This is the graph of all points that have a radius of 3. This is the, how do I say that? All points on a graph around the origin where r is 3. It's a circle. That's a circle. This is a circle in rectangular form. This is a circle in polar form. That's kind of cool. Next one's kind of cool also. Currently, I have a theta. It's in polar form. It just has a theta. I need to get it out of theta and into x and y. Is there a relationship? Is there a direct relationship between theta and x and y? Yes, there is. It's right there. Here's the relationship. Let me write it. Tangent of theta equals y over x. That's the relationship that I'm going to use. So, oh dang. This is what I need to replace. Tangent of 11 pi over 6 is See what I did there? Tangent of 11 pi over 6. What is tangent of 11 pi over 6? It is, it's 1 over radical 3, but it's negative. Watch this. Multiply both sides by x. Y equals mx plus 0. This is a line that passes through the origin that has this slope. This is a line. On a graph. Doesn't matter what the radius is, as long as the angle is 11 pi over 6, that's a line. In fact, I'll show it to you. 11 pi over 6. 11 pi over 6. That's this line right here. Passes through the origin, has a slope of negative 1 over radical 3. That's kind of cool. All right, and last one. This one I don't see like a direct relationship to, but if I kind of play around with it a little bit, cosecant is 1 over sine. Multiply both sides by sine. Wait a minute. This looks familiar. Does this look familiar? Horizontal line, y equals 1. Now, I wouldn't have known that. Like, I wouldn't have known that by looking up here, but that's kind of cool. Okay, and then let's go the other way. This one is the direct opposite of what we just did. There's a direct relationship between x squared and y squared. It would be either way. This one's weird because it has an additional constant in it, but we can take an equation that has an x in it, get the x out of there, and get it into r and theta form. So I would replace x with r cosine theta. That's what it's equal to. And then we usually solve it for r. Don't let the a freak you out. It's just some additional constant that was thrown in there. I don't know why. Last one. It's in terms of x and y. Get them out of there. Get rid of the x and y. We want this in terms of r and theta. So now we need to make two substitutions. Let's make a substitution for x, and let's make a substitution for y. X is r cosine theta. Y is r sine theta. And if it's okay with you, as I make these substitutions, those are the two substitutions that I just made. I didn't like the fact that the 2 was over there because I'm getting ready to solve this for r. So I went ahead and moved the 2 over, and now let's try solving this for r. So I got 3r cosine, 5r sine, pull out an r, and divide. There you go. Polar form. Again, in polar form, we typically solve for r. And we have an r and a theta in there. All right, fun stuff. Enjoy.